objectives to create a specified result or service. This presentation aims to help in understanding more in-depth knowledge of the following while we take on the topic of planning and scheduling. Project planning is defined as developing the basis for managing the project, including planning objectives, procedures, organization, chain of activities, resource types, numbers, timing, routines, and finances. Project scheduling is one of the critical management tasks as it dictates time frames in which the project will be completed, the budget cost in terms of resource requirements, and the sequence of tasks to be completed. It is defined as the process of determining when project activities will take place depending upon defined durations and precedent activities. Scheduling is laying out of the actual jobs of the project in the time order in which they have to be performed. The schedule shows the starting and completion dates of each activity and the sequential relationship among various activities. Scheduling converts the project action plans for scope, time, cost, and quality into an operating table. It is more than just a roadmap, giving the direction to the project team. Project planning is at the heart of the project life cycle and tells everyone involved where you're going and how you're going to get there. This phase describes the tasks and steps necessary to plan and schedule the activities that the project manager and the project team should perform to achieve a successful completion of a project. Project plan is prepared, which is defined as management summary document that describes the essentials of a project in terms of its objectives, justification, and how objectives are to be achieved. The process of planning primarily deals with selecting the appropriate policies and procedures in order to achieve the objectives of the project. The purpose of project planning phase is to establish business requirements, establish cost schedule, list of deliverables such as product, services, namely engineering report, proposal, design drawings, design documents, and delivery date. Other purpose is to establish resources plans, obtain management approval, and proceed to the next phase. The planning phase is when the project plans are documented, the project deliverables and requirements are defined, and the project schedule is created. It involves creating a set of plans to help guide the teams through the implementation and closure phases of the project. The plans created during this phase will help you manage time, cost, quality, changes, risks, and related issues. They will also help you control staff and external suppliers to ensure that you deliver the project on time, within budget, and within a schedule. The project planning phase is often the most challenging phase for a project manager as you need to make an educated guess about staff, resources, and equipment needed to complete your project. Basic processes of project planning are scope planning. Scope planning means specifying the in-scope requirements for the project to facilitate creating the work breakdown structure. Preparation of the work breakdown structure. This means spelling out the breakdown of the project into tasks and subtasks. Project schedule development means listing the entire schedule of the activities and detailing their sequence of implementation. Resource planning means indicating who will do what work at which time and if any special skills are needed to accomplish the project tasks. Budget planning means specifying the budgeted cost to be incurred at the completion of the project. Procurement planning, focusing on vendors outside your company and subcontracting. Risk management, planning for possible risks and considering optional contingency plans and mitigations and strategies. Quality planning means assessing the quality criteria to be used for the project. Communication planning means designing the communication strategy with all project stakeholders. The planning phase refines the project's objectives, which were gathered during the initiation phase. It includes planning the steps necessary to meet those objectives by further identifying the specific activities and resources required to complete the project. The following typical steps on plan preparation are conducting site inspection, plotting derived on-site data, preparation of project cost or budget, and programming of project timeframe, then finally project approval. Site investigation is sometimes referred as field investigation. This means visiting the project's location, verifying if the site is feasible by planner's discretion, data collection and on-site chance for both parties, the project in charge and client, to get involved and exchange ideas. This is to settle the agreements and avoid or resolve unlikely disputes beforehand. The next typical step would be plot or transforming the gathered data into drawing plans. This involves preparation of proposed perspectives, elevations, sections, details, and general notes, which will be essential during the construction phase. Estimate is also referred as the programming stage. This is where we prepare detailed quantity computation, work item cost estimate, numerical program of works, time schedule frameworks, and specifications. Approval. Approval might be the last step for the entire planning phase. You may now enter the next phase, that is if there's no more external or internal change as per client's demand or decision. There are some instances that these proposals might be still subjected for revision, whether minor or major. Well, in that case, there's a possibility that there's a need to repeat the steps until the client's demand or favor has been fulfilled. Well, let's assume the proposal has been approved. This may now be scheduled for the next phase, which is the bidding process, and after that, it shall be handed over to the contractor for project execution, the actual stage. Taken together with the project plan and budget, the schedule becomes the major tool for the project management projects. In addition, the integrated cost schedule serves as the fundamental basis for monitoring and controlling project activity throughout its life cycle. The project schedule shows the timing and sequence of tasks within a project, as well as the project duration, and consists of tasks, dependencies among tasks, durations, constraints, milestones, and other time-oriented project information. The schedule specifies the relative beginning and ending times of activities and their occurrence times. The schedule may be presented on a calendar framework or on an elapsed time scale. Project scheduling is a necessity to predict completion time, control costs and resources, to serve as record, and to manage changes in uncertainties. When estimating work effort and task durations, the planning team must address unknowns or faulty assumptions. This may be accomplished by defining contingency reserves for the amount of time and cost that needs to be added to the project to account for risk. One way of scheduling for a known problem is to add a fixed percentage to the schedule as a block of time or to add contingency percentage to each of the tasks. This extra percentage to be added depends on such items as the project size, complexity, confidence of estimates, or the expectancy of requirements changes. Most commonly used tools: the bar chart or Gantt chart. Henry Gantt studied in great detail the order of operations in PERT and is most famous for developing the Gantt chart in the 1910s. A Gantt chart is a popular type of bar chart that illustrates a project schedule and has become a common technique for representing the phases and activities of a project so they can be understood by a wide audience. A Gantt chart provides a graphical illustration of a schedule that helps to plan, coordinate, and track specific tasks in a project. A Gantt chart is constructed with a horizontal axis representing the total time span of the project, broken down into increments, for example, days, weeks, or months, and a vertical axis representing the tasks that make up the project. Critical path method and project evaluation review. The 1950s marked the beginning of the modern project management era. Two mathematical project scheduling models were developed. The critical path method was developed in a joint venture by DuPont Corporation and Remington Rand Corporation. This is for managing the plant maintenance projects. The critical path determines the flow or schedule flexibility for each activity by calculating the earliest start date, earliest finish date, latest start date, and latest finish date for each activity. Unlike bar chart, it uses arrows to represent activities, and length of arrows has no relation with activity duration. Program evaluation and review technique is developed by Bruce Allen and Hamilton as part of the United States Navy's Polaris missile submarine program. PERT is basically a method for analyzing the task involved in completing a project, especially the time needed to complete each task, the dependencies among tasks, and the minimum time needed to complete the total project. Like CPM, PERT is also a network-based planning tool developed by U.S. Navy in 1958. It was used for scheduling Polaris missile project. But unlike CPM, PERT is used for novel projects like research and development or R&D, where it is difficult to estimate activity duration accurately. CPM is used for projects with prior experience such as civil engineering work. It is a probabilistic approach for estimating project duration of an activity and event-oriented network program. PERT uses 3 time estimates for each activity with a view to overcoming uncertainty in time estimate. Optimistic time estimate, it is a minimum time, for example, the shortest possible time required to complete the activity in ideal conditions. Pessimistic time estimate means the maximum time required to complete the activity in the worst condition. Most probable time estimate, it is the time required to complete the activity in normal circumstances. From these 3 time estimates, we calculate average time or experience time. PERT assumes optimistic time and pessimistic time are equally likely to occur, while the most likely time is 4 times more likely to occur than the other. This is an example of PERT schedule, where you can see here it is event-oriented, and under these events are the time control. Time control consists of probable event start date, probable event end date, and above this probable event start date is the event sequence code, and beside the event sequence code is the duration. Interestingly, both were computer-based for network analysis, PERT using probabilistic time estimates with CPM using deterministic scheduling values. However, the differences are as follows. The success of a project depends on how well you plan it. It can get confusing when it comes to picking a project scheduling software considering the number of applications available in the market. These comprehensive resource and project scheduling tools will guide you in choosing a solution that fits your requirement. You can always use a document or spreadsheet to plan a schedule, but a project schedule software helps better plan and execute a project. There are some honorable mentions: Spreadsheet or MS Excel, MS Project, Primavera, Costex, SagoPlan, and Basecamp. Contractors and owners are often concerned with the labor activity at job sites. For this purpose, it is convenient to have a knowledge on handling resource productivity by effective scheduling. Resource scheduling is divided into 2: manpower and equipment. Manpower scheduling is the process by which the daily manpower level for each craft or skill is selected to complete the work in the most efficient. Manpower should be scheduled so as to avoid interruptions of productive time, repeated stacking up, and de-stacking or hiring or firing of workers. It is to avoid repeated movement of workers, to avoid work like jam or peak demands for equipment such as cranes, trucks, loading the work area with more men than it can adequately and/or safely hold, or workspace density saturation. An equipment schedule is a listing of the equipment required with quantities. Generally gives some high level of information about the equipment. The selection of the appropriate type and size for construction equipment often affects the required amount of time and effort, and thus the job site productivity of a project. It is therefore important for site managers and construction planners to be familiar with the characteristics of the major types of equipment most commonly used in construction. In project management terms, an S-curve is a mathematical graph that depicts relevant cumulative data for a project, such as cost or man-hours plotted against time. S-curves are useful for many different purposes throughout the project lifespan. Some of the most important uses are as follows: performance and progress evaluation. First and foremost, the S-curves are used in evaluating the progress of the project in questions and its performance. There are a lot of factors that need to be evaluated in the process of finding out the current status of the project and the future forecast about the project. They are performance measurement baseline, earned value, and the actual cost. This is very powerful because if you want to know if the project is overrunning the budget or some other risk task is behind the schedule, you can take a glance at the graph and it will immediately answer your query. Number 2. Cash flow forecast. The next use of S-curves is the development of cash flow and the forecasting the changes that the cash flow would bring. Well, cash flow is the timing and the movement of cash with respect to the tasks and events happening during the project execution. Cash flow curves help us evaluate the need for cash and the actual timing when the payment is due under obligations accepted by the company. Number 3. Quantity output comparison. Another important use of S-curves is to evaluate the quantity output that the project will yield. This is used for prominently in the construction manufacturing industries. S-curve characteristics. Projects generally start slowly and then accelerate in the middle before slowing down again at the end. This produces a curve which resembles an S, flatter at the start and then raising quickly before flattening out at the end. The middle part of the S, or the point of maximum growth, is called point of inflection. During this period, project team members are working heavily on the project, and many of the major costs of the projects are incurred. After the point of inflection, the growth begins to plateau, forming the upper part of the S known as the upper asymptote and the mature phase of the project. This is because the project is mostly finished at this point and is winding down. Schedules are constantly subjected to change. In most cases, schedules usually get longer as opposed to getting shorter. This could be due to a number of reasons. This can ruin your schedule because you will not be able to complete it in the time available. This is where fast tracking and crushing come into the picture. The reason for project crashing or fast tracking is to compress the project schedule and deliver the product, service, or result earlier than what was originally planned. It can be used when a project falls behind the schedule and needs to catch up, or if one wants to finish the project sooner than what was originally scheduled. Fast tracking is the process of performing tasks in parallel so as to be able to finish the project sooner. However, it is important to note that overlapping tasks in this way leads to an increase in the risk of rework. Fast tracking involves performance of activities in parallel, whereas crashing involves the addition of resources to a project. In fast tracking, there is increased risk, whereas in crashing, there is increased cost. Crashing is expensive because we are adding more resources to the project. Undoubtedly, if you add more resources to an activity or project, it is going to cost you more. It only works for critical path activities where it is possible to shorten schedules as critical path is of the longest duration path. There is no reason to fast track or crash any activities that are not on the critical path. This is because you will not be able to gain any time whatsoever on your overall schedule if you cannot shorten your critical path. Logbook. It is important to track action items, issues, and risks while managing a project regardless of project size. Handling multiple trackers for each is quite a challenge, especially when the project is big. This logbook is a single place where all trackers can be stored. It also provides a graphical presentation of the overall status of the project logs as well as individual detailed statuses. This logbook also keeps the log of decisions or changes made during the project life cycle. The project plan describes the ends. The project schedule defines the means. Neither the project plan nor the schedule is a product of any inherent value other than helping the stakeholder or clients to meet their operational objectives and long-term strategic goals. Planning phase includes selecting best construction methodologies, preparing the construction schedule or program, and organizing resources. It also encompasses daily and weekly planning through the life of the project to ensure all tasks are completed. Project plans are formal and approved documents to guide execution and control, as well as setting baselines for scope, cost, and schedule. The primary purpose of project schedule is to guide the team to the end. Schedule is the measuring stick for assessing the project performance, evaluating progress, and getting to project closure as soon as suitable. Building schedule formulates the what and how into the when of the project. The project schedule should reflect all of the work associated with delivering the project on time. Without a full and complete schedule, the project manager will be unable to communicate the complete effort in terms of cost and resources necessary to deliver the project. For further inquiries regarding the PERT, you may refer to sources. And for those who want to learn more estimate techniques, here are also some of the recommendations for your